Okay, then I would say let's start this online training. I hope you can hear me now and you can see my PowerPoint presentation. Yeah, welcome to our online training, the second part of the series RFEM for students. I'm very happy that you participate to this training. Short information about the organizers and about the people who are who are the presenters of this course. First of all, my name is Daniel. I'm responsible at Dlubal Software for the customer support and also for the marketing, responsible for the e-learning platform where we have a lot of videos concerning RFEM and also other products of Dlubal. Yeah, and concerning the e-learning platform, my colleagues Praxitelis and also Yannick had done a lot of things. Yeah, and then I would say, Praxitelis, could you introduce yourself?
Yes, of course. Hello, everyone. My name is Praxitelis. I'm responsible at Dlubal for marketing public relations, also for creating e-learning videos and tutorials. Right now, we're building up our e-learning platform. It's going to be very interesting. There are going to be lots of videos. I am assisting Daniel today in this online training. I will answer as many questions as possible in the chat, and the interesting ones I'm gonna tell Daniel to show them to all of you. So I hope you have fun and welcome.
Thank you, Praxitelis. Yannick, maybe your part of introduction.
Yeah, hello, my name is Yannick. I'm also responsible for marketing and public relations here at Dlubal. And similar to Praxitelis, I work on tutorial videos for YouTube, etc. And yeah, I hope, and I'm also gonna help you with questions, and I'm gonna have a great time today.
Okay, thank you very much. Then I would say, let's go ahead with the control panel of GoToWebinar. So for those who are attending this course, this training for the first time, short information about that. Here you have the possibility with this arrow, you can show or hide your control panel. You can adjust your audio settings. So when someone can't hear us, then it's maybe because you have the wrong speakers, wrong boxes chosen. And here you have the possibility to ask us questions. Yeah, Praxitelis and Yannick will answer these questions to you. And when some questions are very interesting for the whole publicity, we will show you then to the whole publicity. Good. Next point to the content of this online training. Yeah, we have today the second part of this online training, RFEM for students. So we are focused more on modeling. First of all, a 2D frame with a hinged column. Yeah, so it's just a frame structure, member structure, and after that we are going to do a concrete building where we have also some surfaces with columns and a lot of loads and so on. Yeah, and at the end of this training, we have the possibility to ask us questions, and we try to answer them as well as possible. Good. Then I close my webcam. I go to RFEM, and then I have a nice poll for you because yeah, we have today the second part of this RFEM training. So I want to know from you if you have attended the first part of the online training RFEM for students. 70% have chosen, have answered. Maybe we'll wait for the rest. 10 seconds more. Good. Then I will close this poll, show you the results. Yeah, so here we can see that most of you have attended the first part of this online training RFEM for students, because that's good. Then I wouldn't tell you the introduction of RFEM, so on the user interface, I wouldn't explain it again, and we can start right ahead. And this will make it everything easier and faster to do that. So good, back to RFEM. So I think for most of you should be the user interface familiar. Today we are going to do this example first of all. So here a frame with a hinged column, yeah. So concerning this, we will model it together, then we will put loads together on that. And don't worry, the training is recorded and you get after the online training all materials and all RFEM models and also the recording and also the certificate of this online training. Good. Then I would say, let's start modeling in RFEM. So first of all, we create a new model. You can click here in the menu bar on the file and then choose new, or here in the symbol bar, you can choose new model. It's up to you. Both is possible. And yeah, here we put the model name to D frame. Yeah, and then let's choose the right folder. I put it here to examples. Sorry. And then, very important point, we choose the type of model 2D XZ, because this is used for frames and shear walls and so on, because we have here parallel loads. And you have, I can show you after that the boundary conditions. Yeah. So in this case, we have a 2D system. So just vertical and horizontal loads will be transferred. Okay. Then here, classification of load cases, we don't need anything. So yeah, I have here the Eurocode and the German national annex, but in this case, doesn't matter. So you can here choose non-standard, node standard. And my global z-axis is orientated downwards. Okay, then short point about the units and decimal places. For those guys who are using different units, you have the possibility here to change that. If you click here, units and decimal places, you have here the possibility to change the lengths, cross sections and other things here. But we in Germany, we are using the meters and so on. So I click on OK, then OK again. Good. And then RFEM creates me this new model and we can start. So first of all, we create a new single member. So we create the columns of this frame. Here is important that you choose the member type beam. I explain it to you later. What does it mean, beam? Yeah. And then we create a new cross section for the member start. So I click here on the new cross section, choose here a profile of HEA. Very common profile in Germany. And then I choose here HEA 180. And I have here the normal steel as 237. If this material isn't there, you can modify it, you can edit that. Just click here on Edit Material. Choose here steel as 235, or open the material library, and then you have the possibility, the chance to choose one of the big material categories. Just click here on metal, then steel, yeah, and I refer to the Eurocode, and yeah, I refer to the Eurocode, the newest one, and then I click on steel as 237. What does it mean, this 237? It means that we have a yield strength of 23.5 kilonewton per square centimeter, or also 235 Newton per square millimeters as a yield strength. Yeah, good. Then I apply that with OK, again with OK, OK, and then OK. And then I start at the origin node here with the coordinates of 0, 0, 0. I start and make this 9 meters high. Yeah, you can put it here, and at a distance of 8 meters along the x-axis, I make the second column. And here you have also the possibility, when you go to a node here, to a grid point here, yeah, and you put now the length with your keyboard. So when you put there now 9 meters, it is also the same workflow as before. Good. Then the next thing is the girder here along these two columns. Yeah, we have here a girder. Okay, here we create also a new cross section and a new single member. So click here again in the symbol bar, click on new single member, and now we have to create a new cross section. And here we have to create this IPE 270 profile. Yeah, let's choose that, click on OK, and now we connect these two columns with the help of the girder. So click from one column to the other column, and with the right click or with escape you can close this dialog. Yeah, short information about the different member types of beam. Yeah, now I have here a connection of two beams, and this connection is rigid, so all internal forces are transferred to the column or to the beam. So there we have bending moments, shear forces, and normal forces if we have the right loads on. So when I double click on this girder here, we have the member type beam, and this member type beam means that all internal forces are transferred from one beam to the other beam. Yeah, I think that's clear. We have also the member type truss. Yeah, truss means that we have on both nodes a hinge. Yeah, and this means that no bending moments will transfer or will act on this girder at the end. Yeah, so we have no bending moments at the end or at the beginning of this girder here. Yeah. Also, we have some other member types, but I will tell you something about these member types later concerning this tension or rip and so on. But remember, The standard is the normal beam type, and when you connect these two beams or these two members, there you have a rigid connection. Yeah, good. Then let's go ahead. Then we have here a slab girder. Yeah. So here we create a new cross section. As I told you in the first part of RFEM for students, you have the possibility to create this cross section also with the help of the project navigator or the data navigator. So on the left side, click here to the cross section. You open the tree structure of the cross section, right click on cross section and say new cross section. Then we create a similar IPE profile, but this is going to be IPE 360. Click on OK. Click then again on OK. And now you have here the new cross section. And remember, in RFEM, if some cross section or some objects and also maybe also some materials, if they are blue here in the project navigator, also in the tables, this does mean that these kind of objects aren't used in this structure here. Yeah. So we define this cross section, but no member has this cross section. So we have to create a new member with this cross section, and after that, it's gonna be black again. Good. So now I want to create here a girder, and here I can the best possibility to do that is to divide this member here. So what we can do, click on one of this member on the, so I click the left column, right click, say divide member, and now you have the possibility to divide it graphically in intermediate nodes or by distance. Yeah, I do it in this case by distance. Yeah, and now you see the different arrows. The different arrows symbolize the member orientation of of this column, and when the arrow shows from the upper to the top of this frame, this means that we have here our starting node and here our ending node of our member. So now I want to divide this in 5 meters high. So I have to choose here member start 5 meter. Then the member will be divided at 5 meters here. Click on OK. And then we have it. Yeah, good. And now we can create our new cross section. Just click here, and not new cross section, our new member. Click here and choose the right cross section, in this case IPE 360, and create it from there to there. Yeah, almost done. Now we create here a third column with a bracing. So to do that, just select this column here. Now it's important to do that from the right direction, the selection. So start at the right and end on the left side. Yeah. And now click with the right click and then say move and copy. Now it's important to set the number of copies more than 1. So here we have 1, and the displacement vector is in this case 4.5 meters. So along the x-axis, click on OK, and we have copied this column from there to there. Good. Now we have here a bracing, yeah, in order to make it stiffer, to stabilize it. Here we have to, you can do it by creating new single members, yeah, that's possible. But RFEM offers you also a more elegant solution to do that. Just click here on Tools, yeah, here in the menu bar. And here you have the possibility to generate models, in this case, members, and here choose bracing and cells. Yeah, I click on that, and now you see different crosses. And a cell is one surface, yeah, which is closed by members. In this case, you see it here, and I want to create this bracing here, but I don't see any cell because here is one member missing. So we have to create a virtual line. I click on Select Virtual Line to close non-closed cells. Click from there to there in order to close the cell. Now you see the cross, and now I have to choose the member type tension, because bracings react only on tension forces, so normal forces who are positive, because we want that the bracing, these kind of members, just transfer positive tension forces. Now I have to create a new cross-section because these HEA profiles are too big for that. So I create a new cross-section. In this case, it's a rolled cross-section. Yeah, I click on that with a diameter of 20 millimeters. Here. The steel material is the same. Click on OK. And now I have to click the right cell. In this case, it's cell number 1. I choose the cell, click then on OK, and the bracing was generated automatically. Yeah, so one big advantage of doing that, it's very fast. And yeah, good. Next point, we want to create hinges. Yeah. So we want to create here a hinge and here a hinge because we want a hinged joint, because there shouldn't be, we don't want to transfer any bending moments. And yeah, in order to do that, we create new hinges, and here we have the possibility to create these hinges by member hinges. Yeah. Click here with the right click, say new member hinge. Yeah. And after that, choose local member access. So we refer our hinges to our member access, to our local member access. And when you don't want to transfer any forces or moments, you have to activate here the hinge phi y. Yeah. If you don't want to transfer any normal or shear forces, you have to activate the displacements ux or uz. Yeah. So keep it in mind. You can use also this icons here on the bottom here. So when you want a rotational release of my, just click here and the phi y, the hinge phi y is activated. Okay, just click on OK. Now go again here on the data navigator and you see, okay, this member hinge is set blue. That's the reason, because we have no member hinges at the members. So right click on the blue hinge, say assign graphically to members. And now you have the possibility to set everywhere some hinges. If you click in the middle, part of a member, it creates hinges on both ends of the member. Yeah. So after that we have hinges on both ends, and if you go to a partial part of this member, you create it only on one end or the other end of this member. Yeah. In this case, I do it here, and also on the other end of this member and of the column here. So I decided to do it here, here, and here. Click on OK, and we see here our member hinges. Yeah. Now to finish that, I create nodal supports here at the columns. Yeah. So I select these supports here, these nodes, create new nodal support. And now I want to show you something. So click here on create new type of nodal support, and a similar window like the member hinges will appear. And here you see the different support conditions and boundary conditions. So what can I see here? In order to transfer, or in order to carry these loads, you have to activate different displacements. Yeah. So if you want to have vertical and horizontal support forces, you have to activate this displacement ux and uz. Yeah. So what does it mean? If you activate uz, yeah, this will block vertical deformations, yeah, vertical displacement. If we activate ux, you will block horizontal displacements, yeah. And if you will activate vy, it will block rotations around the epsilon, around the y-axis, yeah. You have to consider that, and maybe you see some different displacements here. They are grayed out. That's because we use the 2D system, and because we use the 2D system, only some of these displacements are can we activate, and the other ones can't we activate because we have the 2D system, and the conditions, the boundary conditions, are helping us to have here less options to select. Yeah, so keep that in mind. If you have 2D systems according to different xz or xy, please consider that you have here only a limited number of support conditions, and that the other are already activated. Yeah. Good. I click on OK because I want to have here horizontal and vertical forces. Click on OK, and now we have here the nodal supports. Okay. Now I want to end this chapter. Before we're going to add some loads, I want to ask maybe my colleague Praxitelis, are there any questions, or should we show something again?
Yes, Daniel, someone is asking if you could repeat the creation of bracing.
Yeah, of course. I do it here on the left cell here. So on the left side, I create the bracing exemplary. So here in the menu bar of tools, you find the option of generate models and members, and just go here, go to bracing and cells, and you see here the cell, and cells are closed surfaces with members as lines, as boundary lines. Yeah. And when I want to create here a cell, here a bracing, it's not possible because the program doesn't recognize here a cell because it's not closed. So I have to create a virtual line. So just click here on select virtual line, go from here to here. Now the cell is closed. Yeah, the cross appears. And now you have the possibility, after you have selected and chosen the right member types, a cross section, just click here on nodes, select cells, click here, click OK, then again OK, and the cell was created. Yeah. Something else, Proctitalis?
No, that's it, Daniel. You can carry on.
Okay. Yannick, something from you?
No, all questions are answered, so it's fine.
Okay, thank you. Yeah, good. Let's go ahead. Now we are going to create our loads. First of all, before we create some new loads, we have to define new load cases. Yeah, so let's click here on new load case in the symbol bar. And in this case, doesn't matter what's the name of this load case description is, because we have only one load case where we have all forces and loads. So click here, self-weight, activate this self-weight here. And yeah, the action category is permanent. I think that's clear. And then you can click on OK. Yeah, and then we are going to create vertical loads. So in this case, we have to use member loads. Click here in the symbol bar on new member load. Attention, do not use new line loads because new line loads are just for surfaces, yeah, and member loads really for members. So click here on new member loads. Here we have, first of all, load type force, uniform, so we have a straight load here, and we are refer to the global related member length and put their load parameter of 12.767 kilonewton per meter. Click on OK and choose here the first girder, so the upper girder, and then the slab girder. Yeah, with the right click, I close this adding of loads, and I want to edit, to modify these values of loads. So I click on one load, press my control key on my keyboard in order to add something new to my selection. Again, press control key on the keyboard, then press the other load, and then with the right click, I say edit member load. And here I give a new load parameter of 68,371. Click on OK again. And then I want to create horizontal forces, in this case in the global X direction. So I can choose here the members. I choose it like here. So I draw my selection window from the right button to the left corner. Then I press again the control key in order to add something new to my selection. And with the right side, I do the same with the right columns. Yeah, now I have 4 columns chosen, so 4 members. Then I can say, okay, new member load again. And you see, okay, on member numbers, I see the member numbers of those members I have chosen before. Okay, and now it's important to click here on XL because I want to refer to my global X direction and say global load parameter is 4.32, so as kilonewton per meter. Click on OK. And now I want to change it again afterwards. Yeah, so click on one member load here on the right side, then press again the Control key, and then right click, edit member load, and then we will put there a value of 2.7 kilonewton per meter. Good. Now, last point, we have here nodal forces, single forces. So select here these nodes at the top of this frame, or you can do it like that, the same, and then click here on new nodal load and enter there a value of 40 kilonewton in the vertical PZ direction. Click on OK. You see now the vertical loads, and then the same thing for the slab girder here. So click here on new nodal load. Enter here a value of 2.4 kilonewton. Click then on OK and choose these nodes here. Good. I think that is everything. Now you can calculate this whole frame. Just click here on calculate all. And the first step is, or the first result is the deformation of this frame here. When I jump to the display navigator here, so the second tab of the navigator, and scroll down to the results, I can activate a nice deformation of the members. Just click here on the area of deformation, then members, and then say, okay, the cross-section colored, yeah, and then you see a nice deformation of this. I can recommend also to deactivate maybe the isobands, yeah, so the separation lines. Just go here under type of display and click on separation lines. Yeah, and you see it now. Good. Then I go through to the results. So first of all, the deformations, yeah, you can see it in different direction. So UX, UZ, and VY. And then also the members. So here in this case, the bending moments. So MY, shear forces, VZ, and the normal forces, and yeah. And also the different support reactions. You see it here. Vertical forces, horizontal forces. And now, important point. You see here the bracing. Only one brace is shown as a result, and that's because one of these members got compression forces, and that's also the reason why this member doesn't react Yeah, because we have the member type tension, and these kind of members react only when they get tension forces. And tension forces are normally positive normal forces, like in this case. Yeah. So, and when we look to the bending moments, we see here also at the hinged joints that we have here 0 bending moments of this girder here, the same here, and also here. Here in that column, we don't have any bending moments, just normal forces. Yeah, so much to that topic. Okay, Praxitelis, any questions?
Yes, Daniel, there is one question. If we add a lateral load, one bracing member is under tension and the other is under compression, how to model that type of case?
And in that case, it's the same like here. So you can, so you see, okay, if you add lateral load. So we have here lateral loads, yeah, in this case, this horizontal load. And normally the tension members, so in this case, the bracing, act only if they get tension forces. And if they get compression forces, like here in this case, this kind of member, they doesn't react, they doesn't act on that building. Yeah.
Okay, so another one is if you could explain bracing force distribution.
Bracing force distribution. Why? Okay. Yeah, just okay. I understand. Okay, look. So we have here 2 different member types, yeah, and the member type of tension, yeah, this is a specific type of a specific member type, and this will cause a nonlinear calculation of RFEM because these kind of members react just by they react only if they get tension forces, yeah, and tension forces are normally positive normal forces, like here in this case. And after every calculation step or iteration step of RFEM, the program or the whole structure see, okay, if some of my members get normal forces, and then the normal forces are divided by positive or negative normal forces, and when one of the bracings, one of these members here, one of these tension members get negative compression force, so negative normal force, it will fail, yeah, and doesn't have any impact on this structure, and just this bracing is activated and will carry or transfer the loads and get also normal forces, in this case positive normal forces, so tension forces, yeah. And that's also the reason why in the reality all buildings get bracings on both sides. So I have here this bracing and then I have here this bracing, yeah. So this bracing on that side and this bracing from that side. That's because you don't know on which side the wind loads, especially the wind loads, are coming from, yeah. In this case, we make it very easy. So I know because the structure, the deformation of the structure is along the global x-axis. So I know, okay, this bracing will get tension forces because it will get longer, yeah. and this bracing here is going to be shorter, so it will get obviously compression forces. Yeah. Good.
Okay, that's from me. You can continue.
Yannick, anything from you?
Yeah, one question that just came in was if these values can be used for design purposes.
Again, could you repeat the question?
If these values are for the design purpose, usable for the design purposes. So.
Okay, yeah, you can use these values for the design. So when I look to the results and you see the different deformation and also to the different internal forces, yeah, you can use it for the design of different add-on modules. But remember, RFEM is just for the calculation of deformation, support reactions, stresses, and so on. But if you want to design something, so to make some designs in steel structures or timber structures, you have to use our add-on modules. Yeah. And if you want to do seismic loads on that, or to consider earthquake situations, you have to use our add-on module Dynamic. RF Dynam Pro is for dynamic analysis. It's considering different types of earthquake situation and also these kind of loads. Yeah, and here you can see also the seismic different situations and so on. Yeah. Okay, good. Now I would say I have prepared something for you, some tests in order to prove your knowledge. Yeah, so first of all, I want to know this kind of question. So how are two members connected when they have the member type beam? Yeah, so first answer is bending resistant, so rigid or hinged or compliant or semi-rigid. Okay, I close this poll and I show you the results. So most of you were right, yeah. So when I connect two members, they are connected as a rigid bending resistant joint, yeah. I can, and hinged. This is only possible when I have the member type truss, yeah. So then I have on both ends hinges, and semi-rigid. I show it to you now. So when I go here, so let's take this corner here. This is a bending resistant joint, so rigid, so all internal forces are transferred. And this is a hinged connection, a hinged joint, and you have to have this member type beam. And when you have to have semi-rigid connections, just put here some spring constants, yeah, maybe of 10,000 kilonewton meter per rod, and this is, then you have a spring constant, and then you have a semi-rigid compliant joint. Yeah, and when you do that, you see it here at the different at the different hinges here. Yeah, but I will undo that because I don't want to have that. Okay. Good. Then the next question is, this one. Yeah, I close this, show you the results. Yeah, of course, at a 2D system, the deformation and rotations of the boundary conditions are partially blocked. Yeah, that's true, because we have only the vertical and the horizontal forces to carry on. Yeah, and that's also the reason I can show it here, the nodal supports again. So you see here, because we are here in the 2D system, when you added the conditions of this nodal support, you see here, okay, here are some restraints and support displacements and rotations already blocked, and that's because why we are in the 2D system. Good. Then one important point is, one tip for you is in RFEM you have the possibility to summarize different members. Yeah, so if you have here this column here, this column is normally as one column. Normally these two members symbolize one column. Yeah, and if you want to have this as one column, you can create a set of members. Yeah, so you click here on these two members here and make them from two members to one member. Yeah, and here you can choose, okay, column. The description as column doesn't have any impact what you have here as a description. And you have here continuous members, and it's a summarization of different members. And now you see it maybe here. This is the member type. And when I activate maybe a different display model, you see here the set of members number one. And where is the advantage of that? Especially for the design, it can be very helpful, because the add-on modules see this set of members, and they and in the design of this Eurocode, for example, yeah, this will help the different design of doing that. So you have not these different members, so just one single member. You have one single set of member because you consider the whole column here. And also when you want to add some loads, yeah, and you have more set of members, or say more single members, and you want to summarize them, it can be helpful to click here on new member load, yeah, and say, okay, I refer to my sets of members, yeah, and I click here on that, and the load is adding faster, yeah. So when you see, okay, that different single members can have one set of member, please use this function to do that, to do new set of members, yeah. One hint for that, these members doesn't have the same cross section, so that's not necessary. They can have different kind of cross sections. So if I have here cross section of an IPE profile and their HEA profile, doesn't matter for the set of members. So really, it's a summation of different members. Yeah, good. I can repeat it, of course. So first of all, here's the possibility to do that. So here in the symbol bar, new set of members. Click here on these two columns, or these two members. Click on OK. Choose here again, column, maybe column 2. Yeah, and then you see it here. Another point of modeling or doing that is select them. So press then again the control key on your keyboard, right click on one of the members and say create set of members, and then you have the same workflow as before. Good. Yeah. And another point, if you calculate that, you can also watch the whole results diagram of this set of member. This is very useful. It's faster than click every single member and then say, okay, result diagram. It's easier by creating before and set of member and then say, okay, result diagram, and then you can watch it. Yeah. Good. So much there. Good. So last question for this chapter. Okay. I will close this poll here. Show you the results. So what are sets of members? The first answer is correct, yeah. So they must be understood as combined members because they can be, they aren't depending on the same cross section, yeah. So you can have here different types of cross sections and you can set them also as set of members, yeah. So the set of members aren't depending on the cross sections. So they are understood as combined members. Yeah. Good. Then next model to doing that is now the concrete building. So again here on file or on new model, I create new model and I say types of model 3D. And now, yeah, I refer to my Eurocode, and my national annex is in this case the normal central rear code, and the model name is concrete building. I choose the right folder to save that, and my orientation of global z-axis is downwards. Click on OK. And now we change the view in Z direction. Here in the symbol bar, we have the possibility to change the views because we want to create now this concrete building. I show it to you now. Yeah, here we have the floors, the floor slab and the ceiling slab there. Also the different coordinates, no problem. I will make it very easy and slow that you can edit. Okay, good. Let's go ahead. So, first of all, we create these nodes very easily by the help of the table here. So, first of all, I have to check my coordinates. So, now we can start. Okay, first of all, we create here now different kind of nodes. You can do it here very easily by the help of the tables. So click here on standard. With the help of the tab, you can jump from one cell to the other and click here on X is 0, Y is 0, and Z is 0. Yeah, and with enter, you jump to the next row. Good. Now, here the next node has the coordinate of 14, 0, 0. Next row is 0, -12, and 0. And the next row is 14, -12, and 0. Good. Now look to the coordinates. With the help of these corner nodes, we can create a new rectangular surface. We can do that. Just click here, new rectangular surface in the symbol bar, rectangle. And here I have the material concrete C37. You can edit the material here, open the material library and choose the right material. In this case, we have concrete, normal concrete, and I refer to my Eurocode and I choose concrete C37. 37 means that we have a characteristic cylinder compressive strength of 30 Newton per square millimeter or 3 kilonewton per square centimeter, and the 37 refers to the cube compressive strength. Okay, click on OK. And we have a thickness of 200 millimeters here for the bottom slab or the bottom floor. Click on OK. And now we click here on the origin node and draw our rectangular surface. Good. Now the next nodes are again here in the tables are 0.5 minus 0.5 and again 0. And now we see here one node, and with the help of this node we can copy the different additional nodes. So click here with the right click. Click here on move and copy and say, okay, I want to copy it 2 times along the x-axis with a displacement vector of 5 meters. Click on OK, and you see here now the new created nodes. With the right node, I want to copy it again. Here in this case, 3 meters along the x-axis, but just one node. Yeah, now I have these nodes, and now I want to copy it against the global Y direction. Click here on the right click, say move and copy again. X direction is in this case 0. Y direction is -4. Number of copies is 1. Click on OK, and we've copied that 4 meters against the Y direction. So now choose the third node here in the second row. Click here again on move and copy, and this node has a displacement vector of delta y of 4 meters. Click on OK, and now we've already done. Now I want to create here a new semicircular surface. I show it to you again. So here we create now this semicircular surface, and in this case we need here this middle point, and I show you how to create this middle point now. So click here on this line, say divide line, in this case distance by distance, and say okay, because here we have our line orientation, so it's from down to upward. I refer from the end of this line, and here I say 4 meters. I click OK. Now I see here this new created line. And now RFEM offers you a solution possibility to create also nodes when you choose 2 different distances. Yeah. When you click here in the symbol bar, not on new node, but on node between 2 points, you can choose 2 different points, and then you can set the different division of that 2 nodes, of the 2 points, and create a new node. So again, I click here on a new node between 2 points. I click these 2 points here, and now I want to create here this node in the middle of them, and I can say okay, should be divided by 50% or 2 meters. Click on OK, and I have here this new node. It's very helpful to know this function. Now I can create the semicircular surface. I click here in the symbol bar to new semicircular surface. The thickness is the same as before. I click on OK. Now I click at the middle point and go to the upper to the node here. Yeah. Now we created this semicircular surface and also this rectangular surface, and now we can copy it against the global z-axis 3 meters high. Okay. Select everything. Yeah. Draw a selection window. Right click on that. Click here on move and copy. Set the number of copies to 1 and the displacement vector to -3.25. Click on OK. And then you can click here on the isometric view, or by holding the control key and the mouse wheel, you can rotate the whole structure here. Yeah, and you see now also the slab surface and the bottom floor. Good. Yeah, one important point: in order to create here an opening, you have to have one surface, one combined surface. And here we have 2 surfaces, so it's not possible to have here 2. So one opening along 2 surfaces. So I show you this PDF file again. We want to create now here a hole, here an opening, and because we have here 2 surfaces, we have to create one surface. So in this case, it's very easy to create it. First of all, I delete this line here. Yeah, just click on that line and then click on delete on your keyboard, or click here on delete line, has the same function. And then there's a big solution, big workflow, big help for you. When you have here the boundary lines, you can create easily a new surface. So go here again on the creation of new surfaces and click here on select boundary lines. Here in this case, I create 300 millimeters as thickness and click on that on the boundary lines of the slab floor, or the first slab floor. Yeah, and then right click, I close this dialog. Good. So next point or next step is the input of different walls here. Yeah, and the walls have, similar to the surfaces, to the slabs here, also boundary lines. In order to create a surface, you need at least 3 lines as boundary lines. Yeah, so we want to create now the boundary lines of the walls. So click here the left line of this structure here. So the upper line, click here on right click, divide line, and now by distance. Again, you have the possibility to divide the line by distance between the new node. Yeah, and I refer to the starting node here, to the line start, and divide this line here because my arrow shows downwards. I choose here the value of 3.5 meters. So it will divide my line here at 3.5 meters. Click on OK. And the same thing I do here also with a long line here. Click on divide line by distance. Click here on line end, 5.5 meters. Then again here, divide line, distance, and say line end, and in this case 3.5 meters. Good. And the last line division is here on the right side. Right click, divide line, distance, and the line end is here, in this case 2 meters. Good. Now I can create new vertical lines in order to have my boundary lines for the walls. So I click here on new line and draw my line from this corner to the bottom corner, and then right click and right click again. So now you know, I think, one workflow in RFEM of drag and drop. It's very useful to model something very fast. So just click here, this line, press the Ctrl key on your keyboard, then the left mouse click and hold it, and then the drag and drop, you can copy it very easily. And the same thing I do with the others. Yeah. So I copied these lines from the nodes I have created before. And now I have different types of boundary lines. Yeah. Now I can make my walls and my surfaces. So click here on, click here on new plane and select boundary lines. So create new surfaces. And choose here a value of 200 millimeters as thickness. Click on OK. And now choose the different walls here. Different lines in order to create the walls. Yeah. So, and these types of walls are plane surfaces. So they are lying in the plane. And here you see we have here semicircular boundary lines, and there it's not possible to create plane surfaces. Here we have to use this quadrangle. Yeah, you find it here at the symbol bar on the quadrangle and general four-sided surface. So remember, if you have not a plane surface, or you have some boundary lines who are not lying in one plane, you have to use this quadrangle in order to generate or to create a surface. So click here on quadrangle, general four-sided surface. We have the same thickness. Click on OK and choose here this. And choose here this boundary lines. Now I want to copy here this wall from there to there. Also with the help of drag and drop, I can easily copy it from one side to the other. Okay, good. Now it's time for questions. Good. Praxitelis, Any questions? to
Yep,
answer?
Daniel. Someone is asking if you could repeat creating a node for the semicircular surface.
Of course. Maybe it was a little bit too fast, but I can create it. Of course, that's no problem. I make it here again. So I have here a line. It has a length of 5.5. Yeah, 5.5, because now the middle point is not exactly on the grid point. It's somewhere else. So I can create here a new node between 2 points. Here in the symbol bar, you find the solution. You find the possibility to create a new node, but also a node between 2 points. So I click here on that point and on that point. And now I can say, okay, where I want to divide this, where I want to create this node. Here you can enter the values of distances. Click on OK. Here you see now the new generated node, and then you can click here on new surface and click here on semicircle, click on OK, and click here the middle point, and now you can create this semicircular surface here. Yeah. Okay.
Okay, that's it from me.
Yannick?
Yes, there are some questions about the advantages to defining a set of members.
There are some there are a lot of advantages. So first of all the load. So when I want to add some loads, wait, I have to look it up. So when I go back to the 2D frame, so first of all, here we have our set of member. One advantage is that you can combine different members to one member, yeah. And when you want to add some loads, you don't have to pick or to select every single member. You can just click here on the set of member, and every load is going to appear here and will also act on every single member. So that's one advantage. Second advantage is the showing of results. Yeah, if you have a really long hall, for example, and you want to see the results, you have to click every single member. But in this case, wait, I make it a little bit bigger, the member diagrams. You can click here just on the member and select here result diagram, and the result diagram of the set of members shows you all included members. Yeah, that's the second advantage. And one of the third advantage is when you do some designs in our add-on modules, it's better to have an overview about the designs of the set of members, because when you do a design in one of these add-on modules, the program takes every single member, and if you have maybe 1,000 members, it isn't a good overview about these designs. It is a better overview if you have a lot of members included in the set of members. And the design is after that also a little bit better to have a better overview of that. Yeah. And I can show you also another big advantage of them is also, right, you can refer also to our online handbook. So the main advantages is modeling, yeah, the loads, so the load application, and also the design of continuous beams, for example. This would be also helpful. And I can give you here this link. I posted to the chat. And here you can see different possibilities of set of members. But I can really recommend it to use that. Good. Now back to our concrete building. You see the different nodes here on the bottom slab and on the on that bottom slab, and here on the normal first floor slab. And what we're going to do now is adding some columns here. Yeah, you see the nodes here. So click here on new single member. And create here a new cross section. Create a new cross section and click here on rectangular. So rectangular, massive parametric solid cross section. Here we have the width and the height of this cross section, 350 and 350 millimeters. Click here on OK. The material is concrete, the same concrete using for the slabs here. Click on OK. Again on OK. And draw from this node to this node. And now we have one column created. And now we can copy it very easily, again with the help of drag and drop. So click on that column, press the Control key on your keyboard and copy it from one to the other node. Yeah. These members are beams, yeah, so they have the member type beam, so they have their rigid connection, rigid joint, so there will appear some bending moments. Good. Then rotate your window so that you can select all columns at once. So in this case, it's important to draw the selection window from the right to the left corner. And now press Control key again and copy it from to the next node. Yeah. And the same thing we are going to do with that column. Copy it from there to there. Good. Now the basic of this concrete building is already done, and now we are going to add some windows and also a downstand beam. So the next step is that we insert here a downstand beam. Remember, in RFEM, every member has also lines included. Yeah, So when I select one of this member and I do a right click, I see, okay, a line and a member I can choose. And double click, oh, sorry. When I choose the line here and click on edit, I see here in the register in the tab of member is available. Yeah. So please consider that every line can include a member and every member includes a line. So now we are going to create here a line, and then we then we give the line a cross section and a member. So you click here in the symbol bar on new line. Click here this line to right from to the corner point of the wall and then to the column here. Now we select the line, also with the press Ctrl key. Then right click, say edit line. And here we say, okay, member should be available. Good. And here we say member type should be RIP, because downstand beams, yeah, are always or should be always modeled as RIPs. I explain it to you why. First of all, when I click here on edit the RIP, I choose here the positive side of the surface. So here you see my downstand beam, and here you see the surface. So I want that the upper boundary is similar to the bottom boundary of my surface here. First of all, integration width of my side 1 should be this surface here. And I choose here the width B1 to L8, and here the same L8, and choose here also the plane, the surface number 3. So what can I do with the RIPs? For what are they good and useful? The RIPs are very important in order to calculate the internal forces in consideration with the surface results in order to have the right results. So for RIPs, the internal forces are determined according to the requirements of concrete design. Yeah, and the stiffness member, or the stiffness of a RIP member results from the member height, yeah, from the member height, and also from the surface thickness due to the effective widths, so to the integration widths, and therefore the internal forces of a RIP member include the member forces, yeah, but also the internal forces of a surface, yeah, integrated with the help of this integration widths, yeah. So keep that in mind. So every time you model a downstand beam, please use the member type RIP. Yeah. Good. Then I want to change the cross section. Here I click here on create new cross section on member start. I click here on solid cross section and give here a value of 200 millimeters and 150 millimeters as a height. Click on OK. Again on OK. OK, and click on OK again. And we see now the downstand beam, so the rib. In this case, also with the eccentricity. Yeah. And when I show me now, when I go to the display navigator and scroll down to the rendering, click here on model, solid model, and here, and here on surfaces, and I choose here the filled inclusive thickness with edges. You see it here that the edges are connected to each other, are facing to each other. Yeah, good. So much to them. The next point is the creation of a window. In Alfred, we have different kind of work planes, and I want to create this window here on that side. And for that, I have to change my my origin of my grid and work plane in order to create here some new nodes or new modeling objects. Yeah. So what can I do? I click here on set origin of grid work plane. Click that corner here. And now I can change also the work plane in YZ and in XZ. Yeah. And in order to create on that surface here a new window, I have to choose this work plane here, XZ. Now I want to create new nodes. So I go here to the symbol bar, click here on new node. And now I can refer to my current coordinate system or to my grid origin. In this case, I want to refer to my grid origin I said before. And I enter here the value of, I have to look it up, of 5, 0, and minus 2.5. I can jump from one cell to the other with the help of the tab key on my keyboard. Click enter, and with the pressed shift key and the tab key, I can jump back to the other cell in order to enter something. Here I click for the second node 1.5 as X and 0 and minus 1 and click then enter. Yeah, you can see the different types here. You can see also X and this, I don't know the English word for that, X, and here you see the current coordinate system, the normal X and this X. There are differences. Good. Now I can create easily the opening. Create here rectangle opening next to the surfaces and choose here these two nodes, and I've created this opening here. Okay, then I preset my set of origin back to my original coordinate system and change the work plane to X, Y. Good, so much to them. Now I want to add surface bearings, surface support, and line support. So for that, I choose here, first of all, this left lines here, and with right click on that lines, I can say, okay, edit line, and in the tab of support, I say, okay, the support should be available, and I want to modify them. I want to create new line supports, and here I have the possibility to consider spring constants, the restraints, and the supports. As I said before in the first example, you have to activate these kind of supports where you want to have no displacements or no rotations. Yeah. In this case, it's okay if I have only vertical forces. So I deactivate the UX and the UY. I say okay, apply it again with okay, and I see here additional line supports. Good. And the same thing we are going to do with the surfaces. Yeah. Because you can do almost everything also with the help of the data navigator or with the tables. I create now the surface supports with the help of the data navigator. So I choose here the surfaces, open the tree structure, and open here and click on the first plane, on the second plane, so surface, and then right click and say edit, and you see now, okay, surface number 1 and number 2 are selected. I go to the tab of support and eccentricity, and I say, okay, the support should be available. And here I enter the values of, no, first of all, I have to change the units or the decimal numbers because I want to enter these values not as kilonewton. I want to add this here as meganewton. I click here, supports forces meganewton, click on OK. Now I enter the values of 10 meganewton per meter up to the power of 3, here the same. Here is 100, and there I have the values of 50 and 50. I want to consider a non-linearity. Which non-linearity? The surfaces should failure if the contact stress in the Z direction is negative. Yeah. Click on OK. So what does it mean? If I have negative forces, so contact stresses in the Z direction, it will failure, so it wouldn't calculate, and you will get a non-calculation of this structure here. Click on OK. Click again on OK. And you see here now the surface supports and the line support. Yeah. Good. Now I want to end this chapter. Praxitelis, so far, any questions to repeat, or should I mention something again?
No, Daniel, no questions so far from me.
Yannick?
No, for me also, there are no new questions added. So we can just continue.
Okay, good. So now I want to create different load cases and load combinations and so on. So click here on new load case in the symbol bar. and here we enter new load cases. So first of all, load case self-weight has the action category of permanent. I think that's clear, and we consider the self-weight. So the program calculates automatically the self-weight in consideration with the geometry of the structure and also the specific weight. Good. Now we want to create a new load case here. In this case, we have a load case imposed loads. Imposed loads. We choose here category D. Yeah, so we refer to shopping areas. Then create a new load case again. In this case, wind in the positive X direction. Then again, wind in positive Y direction. And then I want also to consider some imperfection load cases. In this case, imperfection towards positive X and imperfection in towards positive Y. Good. Then I close this with OK, because we forgotten something. With the right click on the project here or on the model, right click here on general data, and we have forgotten to create here combinations automatically. Yeah, because then we don't have to create these load combinations manually. The program does it for us. So now I want to refer here to my load combinations and load cases. I click here on edit load cases and combinations, say load cases and combinations. And now we have here more than 3 tabs like before. So the second tab is actions. Yeah, so look at the action category. We have different actions. We have here permanent, imposed, and wind. And when we jump to the wind action, you see here simultaneously, differently, and alternatively. What does it mean? If I have this activated, so the wind actions are set as alternatively, this means that these two load cases aren't combined with each other. Yeah, so load case 3 and load case 4 will never be combined together. Simultaneously would mean that they will combine every time together. Yeah. Differently, if I have more than different load cases with the action of wind, I can set them as groups, and each group will exclude each other. Yeah. But in this case, it's the same effect when I have this alternatively. Good. Next step, combination expressions. Here you can see the different design situations. So you see here the partial factors when you want to create a load combination, and also the coefficient factors. Yeah, good. In this case, you see also the different ultimate limit states, yeah, or the serviceability states. Here you see the ultimate limit state, so permanent, transient, and also the serviceability state. Yeah. In this case, I don't want to have this serviceability. I'm only interested in the ultimate limit state. So I click here on don't use. Yeah, they are grayed out now. I'm also interested in the ultimate limit state, And because we have here imperfection load cases, yeah, so imperfection towards positive x and positive y direction, we can here set some do some settings for the imperfection load cases. So click here on settings for imperfection load cases, and now deactivate here, remove all load combinations without imperfection, and also remove coexistence. But activate subject to specific load cases, because when I have this imperfection towards the positive x direction, I don't want to have a combination with the wind direction in positive y direction, because this would be a bigger advantage, and I want to have these kind of results who are really important for me. Yeah. And then, so I say never with load case wind in positive y and wind in positive x. Yeah. Exactly. Good. Good. This is an important point to have to consider that. Then I jump to the action combinations. Here you see now the different action combinations of the partial factors and combination factors, and also the leading action. Yeah, in this case, it's the imposed action here. Yeah, the leading action, and all load cases or all actions without the leading, they are combined with the partial factor and also the combination factor. Good. Now the load combination. What is a load combination? A load combination is a combination of all load cases to one bigger load case. Yeah. And this load combination considers the partial factors and also the combination factors. So when we look to the load combination of load combination 10, we see here we have the load case self-weight, load case imposed loads, and wind in positive y direction. And here also the different partial factors and combination factors. Yeah. And now the result combinations. What is a result combination? A result combination is a combination of all existing results of load cases or load combinations. So in the result combination, the maximum and minimum values of internal forces, deformations, and support forces are determined. So the model is not recalculated. So the results of the involved load cases are superimposed. Yeah. So when I look to one of these result combination, I see the maximum and the minimum of different results. And that's very helpful. Good. I click on OK. Now I have to add different kind of loads here. Good. First of all, the load case solve rate is without load. I just want to consider the solve rate of the whole structure. No additional loads. So I jump to the next load case. I click here on next load case with the arrow, imposed loads. So what can I do here? I click here on new surface load. And create here a magnitude of 5 kilonewton per square meter. Click here on 5 and should be related to the true area, because we have here this imposed loads. Click on OK and choose here this bottom slab. And when I want to, and when I rotate, also this semicircular bottom slab. The same with the floor slab, but I have to edit this afterwards, because here we have another value of 5. Instead of 5, we have here the magnitude of 2. Click on OK. Then I jump to the next load case. In this case, the wind in the positive X direction. I rotate a little bit my my structure, and I click here on New Surface Load. Now I refer to my global X direction, so I have to click here XL. Magnitude is in this case 0.4. So for the compression side, and now I choose here the lines. And now, because we have now surfaces, I have to use line loads, yeah. And here I enter the value of 0.65, choose the right direction, XL, and click on OK. So that was the compression side. And now let's come to the suction side. So I rotate a little bit my structure, and here I choose these surfaces. Click on New Surface Load again, and I relay to my projected area, and my magnitude is 0.25 kilonewton per square meter. And here again, new line loads. And here we have a load parameter of 0.41. Click on OK. And the same procedure we are going to do with the wind in the positive epsilon direction. Yeah. So first of all, I select here these surfaces here. Then I click again on New Surface Load. In this case, I refer to epsilon P direction, also to the projected area, and they have a magnitude of 0.4 again. The same here for the line loads. And now I want to show you a different option to enter the values. So also with the help of the table, is it possible to create loads? So go to Table, Loads, and now you want to create line loads. Yeah. So click here on Line Loads. Choose the right lines. In this case, this one. Click on OK. Yeah. And now you have just to enter a new load parameter. And in this case, for the suction side, we have 0.41. And you see also with the help of the tables, you can create such loads. Good. next point, the imperfection towards the positive x direction and positive y direction is, first of all, I want to show you the member axis. So when I click on one of these columns and with right click, I can activate the member orientation and also the local access system of members. Good. Here I see the different local access systems, and they are now important for the insert of imperfections. So now one big advantage in RFEM is that you can have different visibilities. And now when I just want to see all my columns, I go to my tab, to my view navigator. I go to the area of visibilities, and then I choose here members by cross-section, and I activate the cross-section rectangle 350 because I want to see only my columns. Yeah, this is very helpful. Now I say, okay, insert, loads, and the last point is imperfections, and there I say graphically. Yeah, I refer to the Eurocode 2, so to concrete structures, we have no pre-camber, just an inclination of 100, so of 200. Yeah, I click OK, and now I can choose all the columns with the help of the selection window. And the same procedure we are going to do with positive y direction. Here the same thing, insert, loads, imperfections graphically, but in this case we have another local axis. So our direction refers now to the local axis y of our members. Click on on y, click on OK. And we see now when I activate different display model, the different imperfections. Good. That was it with the adding of the loads. Now I can calculate everything. I click here on calculate all, or another possibility is also that you go to calculate and say here to calculate and choose here the result combination and then click on OK. Good. So before we do some results interpretation, Praxiteles, are there any questions?
There's an interesting question, Daniel. Someone is asking, are there some modules for physical non-linearity? Like concrete, for example, calculate structure with a difference between tension and compression material characteristics.
Yeah, that's possible. In the add-on module, you can in the add-on module RF concrete surfaces, you can consider such non-linearities like creepage and shrinkage. That's possible. And you have here, of course, you have here a normal concrete floor. But if you want to design it, you have to use here the concrete surface. And we have also another add-on module his name is RFEM nonlinear, and there you can calculate and consider all non-linearities, especially for the concrete design. And also another point is, if you want to consider non-linearities in your materials, go here to the materials, choose here concrete or steel, up to you, go to edit, and here you see also the material model. The standard is that you have every time isotropic linear elastic, yeah? But if you want to have some orthotropic or isotropic masonry, something like that, you can consider it here at the material model. That's possible, yeah? Good.
Okay, I think that's it from me.
Yannick?
From me, there's no new questions. That's fine.
Okay, good. Okay. For those who are interested in FE meshes and the sizes of refinements and so on, we can make here an example of refinements. So before I do the result interpretation, I want to add the FE mesh refinement here, because in order to interpret the results at some critical points where singularities can be, I want to add here refinements in order to not to avoid the singularities, but to have the better results. So for that, I create here at that point, I click on that point, so it's the corner here of that wall here. I click here on that node and right click and say FE mesh refinement. I say I create a new one, create new FE mesh refinement. And in this case, it should be circular. The radius should be, now I have to look it up, 1.5 meters. Yeah. So here, with the help of the right bitmap, you see the radius. The inner FE length should be 0.1 meter and the outer FE length 0.5. Let's click on OK. Then again on OK. Now you see here this FE mesh refinement, this sphere here, and now we can look to the FE mesh. So I click here on calculate, generate FE mesh, and when I look to the wireframe display model, and I scroll, I zoom into this FE mesh refinement, I see, okay, here we have this inner FE length of 0.1 meter, and it will rise up to 0.5 meters along the radius of 1.5 meters. Exactly. Good. So then we can calculate again everything. So say to calculate result combination, I want to select for my calculation, and now the program calculates everything. Good. So what we can do. So when I activate I have to choose the right result combination. I deactivate the loads and I activate the result. So what can I see now? First of all, the deformations. Yeah. And here you can see also of the members that we have this line deformation. When I want to show me that as a cross section, I go here under display, results, members, and click here cross section colored. Good. So here we can see the result combination. Yeah, so the global deformation, we can choose here between different directions, the X direction, Y direction, Z direction, and so on. Yeah, I think that's pretty clear. We can show us the members, so the internal forces of the members. And when I say, okay, I just want to see the columns, I click here on view and say, please just show me the columns or the members with that type of cross section. I see the different cross sections and the different members, and also now I can choose the different internal forces. So yeah, for the columns, the most interesting part are the normal forces, the compression forces, in that case, because we have negative normal forces, some shear forces, but also some bending moments. Yeah. Good. So much to them. Now we have also the possibility so I cancel the visibility mode, and now I have also the possibility to have the surface internal forces. So here we have the basic internal forces mx. So I activate the local axis system of surfaces, and I deactivate it for the members. And what does it say to me? The basic internal force mx and my. Mx are these bending moments along the local x-axis of my surface. Yeah, here you can see the when I just activate this one. Here you can see the local x-axis, and mx does mean that I refer to my local x-axis of my surface, and the same for my. Yeah, and when I look to these kind of distributions here, it's very clear here. Yeah, so yeah, also twisting moments, normal forces especially in the walls. So not here, but in the walls you can see the normal forces. Yeah, and x maybe, and y. Yeah, you see here the most are in that walls, and so on. Good. So also you have the possibility to see the contact stresses. So to see the soil presses, very important maybe for you, especially under the columns. They are the biggest contact or soil presses. When you want to see the line supports here along this line here, just click here on support reactions, and you see now the support reactions. When you want to have a distributed, integrated support reactions, support loads, go here to the display navigator, go to the area of results, and go to support reactions and activate the smooth distribution, and deactivate for better view the actual, and now you see the smooth distribution of the line support. Good. Another possibility is also that in RFEM you have also the possibility to do some sections, yeah. So to cut here and do a section in order to see the different results. We want to do that. I activate maybe I think the deformation is the best thing. I create here, define section and result diagram, or at the data navigator, I click here on new section. Say the section name is 1 - 1. The edge point of section I can choose here from there to there, for example. Yeah, doesn't matter. Just an example. I can now the different edge points of sections are chosen. I can modify. I can change them at every time. And then I say, okay, the section on surface, the projection direction should be to the global Z direction, and not on all surfaces, just on that surface. Click on OK. Then I click afterwards again on OK. It opens a new window with the section here. I close that window, and if I have here at the results tab the section activated, I see here the section also in the results, and it's very helpful maybe also for the presentation of here in this case for the deformations, but I can also activate maybe the different internal forces here, for example, MX, for example. Yeah, this is one interesting point. And another point is also the clipping area. So if you here at the menu tab, click on Insert and click on Clipping Plane, you can show you the different, for deformation, for example, also at a clipping plane. Yeah. Choose the right plane, or you can also preset a new work plane. In this case, I choose the XZ plane, but you can choose also this plane or this plane. It doesn't matter. And by putting here an offset, you can choose here the offset of this clipping plane, and the steps, you can make the steps a little bit bigger. So when you say, okay, 0.5, you make this clipping planes bigger, and so on. Yeah, so much to the clipping plane. It's a nice tool to know. And a very cool mode is also the flying mode. Yeah, when you want to impress someone, maybe your colleague at your work, you can impress someone and say, hey, look to my nice structure here. Just click Shift and F, and the view, the camera view, is changed to a flying mode. And now you can see the whole structure as a free camera mode, and with the help of the arrows on your keyboard, you can fly around. And you see here the different deformations. Let's go to the window. Look outside. Okay, who's there? Nobody, and so on. Good. With the keys, minus and plus, you can influence the pace of the movement. Yeah, minus is slower, plus is faster, and with the arrows up and down, so this one, you can go to the next level. Yeah, so much to them. So that was it for that online training. Now I want to start my questions, so my tests, and after that we can start with the questions. Okay, good. Now I have 2 tests for you. The first test covers the topic downstand beams. Okay, most of you have chosen. I close this poll, show you the results. So when you learn at this training, then it's that point that downstand beams should be modeled always as ribs. Yeah, really as ribs, because there you consider also the internal forces of the surface and of the member because of the integration widths. Yeah. And next and also last question is this one. What is a load combination? Okay, I close this window. Show you the results. A load combination combines the loads of the contained loads cases into one big load case. That's true. Yeah. So I have the load cases and I combine them with each other. And there I consider also the partial factors and the combinations factors. And when I combine that to one bigger load case, it's a load combination. Good. Now it's time for questions. Praxitelis, when you want to start.
Yeah. Someone is asking how to prepare the printout report.
Yeah, the printout report is done here by clicking in the symbol bar by print graphic or by current printout report. Important point is that you divide your structure in different structural parts or elements. So you have to create several different user-defined views, for example, of the columns and of the shear walls and of the slabs. I make it as an example. So create here a new, so first of all, I activate here the columns, yeah, and maybe this view I like very much. I said, okay, name columns, click on OK. I can do this also for the surface. I choose here this one. Say OK, visibility by selected objects. For example, like that. Say OK, create new defined view, and say OK, bottom. And then I can say, okay, print graphic here in the symbol bar. And the most effective way to do a printout report is to use this mass print. Yeah. So look, mass print settings. I want a picture, an image of my model here. Say loads. Okay. I select the load cases where I have a load to have these pictures, images, not of the current view, of a defined view, the isometric view. And now I want to have some result images. In this case, I decide to have the UZ direction of which load case or combination. In this case, I decide for the result combination. I make it very fast because there are also some other questions. And not all the current view or the select the user defined views also. So from that to one we were defined before, activate both of them. And now I choose these kind of results who are important for me. In this case, for the members are the, maybe the bending moments and the internal forces. The normal forces are important, and also the global deformations. And for my bottom slab, not the internal forces, but the context stresses. Sigma Z. Click on OK. Click on OK again. Then I click on OK again. And now you can see the printout report on the left side. You see the different topics. Yeah. And when I choose here the loads and I jump to one of these load cases, you see the different loads. Yeah. And there's one problem because we have here a wrong picture of that, but there's no problem. We can edit that picture. So like that, go back, and the picture, the image will actualize, and then we have the right picture here. Yeah, you see it here. And also one big advantage of that results is the different result pictures. And here we see different pictures of the context stresses here, maybe a very important thing, but also for the internal forces of the columns here. Yeah. So much to the printout report. Next question, Praxitelis.
Yes. Could you repeat creating the clipping plane?
Of course. Here at the menu tab or menu bar, you have the possibility to insert the clipping plane or to use that. Click here on Insert Clipping Plane, and now you have the possibility to choose the plane you want to have, also, or to set also a individual work plane. And if you play here with the offset, you can choose the right clipping plane, also can modify the steps here and so on. Also the rotation angle is possible to do, and very helpful when you want to see some results or something like that. When you activate maybe the results, you can see it here. Yeah, so much to them.
Okay, I think that's it from me.
Yeah, Yannick, maybe you have something?
Yeah, there's just one more question about the next coming webinars. Are there any more coming?
Okay. Yeah, normally I've organized just part 1 and part 2, but if you like the training, just write it in our survey, which will appear after the training, and there you can say what could you improve or what should be nice, and write there if you want to have a third part, and also maybe the topics, and we are going to create then a third part of this online training, especially for you students, and that would be fine if we know maybe the topics which are interesting for you. Just write it in the survey, which will appear after the training. Yeah. I see one more question. Question is, how can we get information about the detailing of the rebar? Yeah, to get this kind of information, you have to use our add-on module, RF Concrete Surfaces. Just click here on RF Concrete Surfaces. Choose the right ultimate limit state. So in this case, the result combination, the right design standard, and then the right material. You see also the important material properties for the design of concrete structures, then the surfaces, and then here the reinforcements. Yeah. And here you can preset the different types of reinforcements, also to set the layout, the distances between the bottoms and so on, the concrete cover and so on. Also the diameter, almost everything. Yeah. Yeah. Anything else? So, is it possible to analyze multi-story frame structure building for us? Of course, it's possible to analyze multi-story frames. Yeah. When I go back to this 2D frame, you can, what you can do is just copy it again, here from there to there. I have here also a bracing. Oh, that's not so good. But if you create here again a bracing or something like that, you can calculate again, and that's also possible, of course. Yeah, that's possible. Okay. Okay, pushover curve analysis, we can cover that, of course. That's no problem. But maybe one short information, we have on our website a lot of webinars concerning these topics. First of all, when you hear on our website, I can recommend to use that as often as possible. First of all, I want to recommend you our education, so our e-learning platform. Here you have the possibility to look to the RFEM 5 for Beginners online course and also to the accomplished and recorded webinars. Here, this online course is very helpful to get the basic knowledge about RFEM. Yeah, here's also Praxitelis, and he will explain you the basics of RFEM. This course is orientated for, especially for beginners. And here you have also all recorded webinars, also concerning our American standards, Canadian standards, American standards. I can really recommend it. So you can also filter it by industry, product, when is someone interested into nonlinear analysis, something like that. Just click here, search, and you will find here now some nonlinear FE more webinars, something like that. I can really recommend it. I post also the link into the chat box. And the newest point on our website is the downloads of models. So we have a really big library of a lot of downloadable models of RFEM. So when you look here, maybe to that first one, and when you stay a little bit longer on that picture, it will activate a rotation and an overview on the website of this structure. And this is very cool. You can look at it. And of course, all these models you can download from our website. I post also a link into the chat box. And here's also our reinforced concrete building. But you get after that an email with the certificate, with the recording of this training session, and also with all models to download. Maybe you will find something in the webinars concerning a steel design of RFEM. Our steel tool for designing steel structures is RF Steel. I have to find it. Steel EC3. Now these are models to download. Sorry, when you want to look to webinars, here product. RF Steel or Eurocode, Canadian standard, or also American standard. It's up to you. We have here the possibility to choose that. Okay, good. Yes, is RFEM works with graphical program language like Dynamo and etc. Of course. We have here at products, and now here at solutions, building information modeling. Here you see all areas where we can interact with other programs. And there's also there is also data exchange with Dynamo. Yeah, when I look Dynamo, I think that's possible. Or also with Rhino and Grasshopper, this is also possible. Yeah. So here at the building information modeling, here you can see all our different interactions with other programs. Yeah, good. Good. And then I would say, let's end this online course, this online training. First of all, thank you very much for your attention. We had a lot of fun. I hope you learned new things and you can try it also now on your projects.
I think too we have covered the most of the questions, not to say all of them. What we could also say is that you can anytime contact us in our website. There is a small dialogue on the right side. It says leave a message. So if you have any questions, you can anytime contact us, and we will get back to you as soon as possible.
Okay, then I would say goodbye, have a nice time, and stay healthy.
Exactly. Have a nice week. Bye from me. I hope it was fun for everyone. So, okay, bye.
Yeah, bye.